Here's a solution to your bonus problem from your trigonometry test. The question is, define f of x as sine to the power of 6x plus cos to the power of 6x plus k sine to the power of 4 plus cos to the power of 4. For some real number k, we want to find all the real numbers for which f of x is constant for all the values of x. Now, using my favorite formula, that sine squared plus cos squared is equal to 1, we can get rid of all the cosines in this formula and have it be an equation that only has sines. So let's just solve this for cosine by moving the sine to the other side. So now instead of cosine, I'm going to write 1 minus sine squared. So that would be cos squared. So if I want to get cos to the power of 6, then that's going to be the same as cosine squared to the power of 3. So right now, this is cosine squared, so I need a power of 3 to make it the power of 6 altogether. So now I have plus k sine to the power of 4x plus, and I'll do 1 minus sine squared, so that's cos squared, and I have to square it to make it cos to the power of 4. So now I'll expand this out. So I have 1 minus sine squared 3 times. I'm just putting the k into the brackets here, and I've got 1 minus sine squared twice. So now when I expand, I'm going to start over on the left side. So 1 times 1 times 1.
Mrs. Krensler, please call 101. Mrs. Krensler, please call 101.
So let's see, I've got 1 times 1 times 1, and then I've got 1 times 1 times sine, and I can do that in 3 different ways. So minus 3 sine squared x. And then I've got 1 times sine, and I can do that in 3 different ways. So that's plus 3 sine 4x. And then I've got sine times sine times sine, which would be minus sine 6x. Here I've got 1 times 1 times k. I've got minus 2 sine squared x's, so 2k sine squared x. And then sine squared times sine squared is plus sine 4x with the k on it. Now I'll gather together my like terms. The sine 6's cancel. All my numbers, just 1 and k. My sine squared terms. And my sine to the power of 4 terms. So all together, these ones cancel. Let me start with my to the power of 4. I've got 3 sine to the power of 4 plus k sine to the power of 4. So I can write that as 3 plus k sine to the power of 4x. So that's my reds. Oh, never mind. I missed one. I've got 3 and 2 k's. Now sine to the power of 2, I've got 2 terms. They're both negative. So that's minus 3 sine squared minus 2k sine squared. So I could write that as minus 3 plus 2k sine squared x. And then my just plain constant terms are -1 and k. So I could do plus k minus 1. So now when is that going to be equal to a constant? Well, the trouble is, as long as I have x's, then this is going to be a graph that changes. It goes up and down periodically. So the only way that this can be a constant is if I don't have any x terms, if these things are 0. Then I'll have 0 sine x's, 0 sine squared x's. I'll only have k minus 1, which will be a constant. So I need 3 plus 2k to be equal to 0. So 3 is negative 2k. So k is negative 3 over 2. And then the graph will be a constant value of, we put negative 3 over 2 into this one, we'll just get negative 5 over 2 as the constant value of the graph. So the graph will just look like a straight line at negative 2.5. So that would be the answer to the bonus.